Okay, we are picking up with the Unit 4 Lesson 7 video, again out of Chapter 12 in the textbook. And the first example we're going to look at is example 4, but before we get to that, we have another key concept on the tangent function. So the tangent function, y equals tangent of theta, basically it has a domain of 108. It repeats every 180 degrees or every pi radians, and it starts at basically the way I remember it, the way I was taught it in high school, is that it goes through the origin and then it goes 90 degrees beyond that and 90 degrees before that, and then every pi radians or every 180 degrees there's a vertical asymptote. So you can see there's an vertical asymptote at 90 degrees, at 270, at 450, etc. And as the function approaches the asymptote to the right, it goes towards positive infinity, and as it approaches to the left, it goes down towards negative infinity. Therefore, the range is all real numbers. There is no amplitude because this is not a wave function like sine and cosine are. And it says theta intercepts in one cycle. So basically, the intercepts on the x-axis or the theta axis, they happen at the origin, and then they happen at half of 360 over the period, over b. B is not the period, but half of 360 over b, comma 0, and then 360 over b, comma 0. So this is just the default tangent graph, but then also we could shift the graph theoretically based off the b value. So the first thing we're going to look at for example 4 with tangent is we need to find the period of y equals tangent 1/2 theta, and then we're going to graph the function. So for sine and cosine functions, the period was always 2 pi, or 360 degrees divided by b, but for tangent, it's just 180 over b. So you can see here 180 over 1/2, the b value is 1/2, gives us 360, so this function is going to repeat every 360 degrees, and therefore the asymptotes, they're always at 180 over 2 times b, and this time we get that that's going to equal 180 degrees. So before the default function, the asymptotes were at 90, 270, 450. This time they're going to be at 180, 360, 540, etc., and then 720. So the key now is, because we're going to sketch the same graph that we saw in the key concept, but this time we're only doing one cycle for 360 degrees instead of every 180 degrees. So here's what our graph looks like. Again, we're going to go through the origin, and this time we're going out to 180 and backwards to negative 180, and that's going to make 360 degrees total. We have asymptotes at 180, 540, 900, etc. every 360 degrees. Okay, here's a problem to check your progress for example 4. We need to find the period of y equals tangent 3 theta, and then determine the asymptotes. So go ahead and pause the video, work out the problem similar to how we did in example 4, and then advance to the next slide when you have your answer. Okay, the answer at this time is that the period is going to be 360 degrees, sorry, and the asymptotes are going to be at negative 30, positive 30, 90, and so on every 60 degrees. Lastly, we have another key concept on the cosecant, secant, and cotangent functions. The concept here is that since cosecant is the inverse of the sine function, that you would sketch a sine function as a dotted line, and then the cosecant in solid line is the inverse of those. So while the sine function here goes down, the cosecant will go up. Here the sine goes down, but the cosecant would go up. Here the sine goes up, but the cosecant goes down, etc. Notice how the cosecant function has an asymptote every 180 degrees, because where the sine is 0, the inverse of or the reciprocal of 0 would be 1 over 0, which is undefined, so that makes the asymptotes for the cosecant function. There is no amplitude for the inverse functions, the reciprocal functions. For the secant graph, you would graph a basic cosine graph and then do the reciprocal of that. And for cotangent, you would graph a basic tangent graph and then graph the reciprocal. So while tangent goes through the origin, goes up here, cotangent does the opposite. It starts up towards positive infinity and goes down towards negative infinity. And you can see that while the asymptotes at tangent function were at 90 degrees and 270, the asymptotes default for cotangent are at 180 and 360. Okay, for example 5, we're going to find the period of y equals 3 cosecant theta and then graph the function. So the first thing you want to think about is that cosecant is the reciprocal of sine, and the sine graph has a default period of 360 degrees. So we're going to take the values of the theta intercepts for the sine function, which are at 0, 180, and 360, and because they're zeros and theta for the sine function, those become the asymptotes for the cosecant function. And this just has, the sine graph has a period, not a period, an amplitude of 3, so it's going to be higher up on the y-axis than a basic sine graph, and so therefore the cosecant graph will also be a little bit higher up. But the period's not affected because there's no value in here for b. So here's the graph of that function. 3 sine theta starts again at 0. It's going to go up to 3, come back to 0 at 180, go down to negative 3, come back to 0 at 360. So you want to sketch that first as a dotted line, and then do asymptotes through wherever the sine function touches the theta axis, and then basically just do the opposites in solid line to make the cosecant function. Okay, lastly, we have one to check your progress on. For example 5, we want to find the period of y equals 4 secant 2 theta, and then find the asymptotes. So go ahead and pause the video, look back at the key concept if you need to, work it out, and then when you have your answer, go on to the next slide. Okay, our answer for this one is C. The period is 180 degrees. This 2 right here is going to, basically you take 360 and you divide it by the 2. That's how you get your period. And then your asymptotes would just be wherever the zeros are for a cosine graph. Okay, that brings us to the end of Unit 4, Lesson 7.